Yeah, thank you. Hi all, good afternoon. Today I am going to present a presentation on IoT testing, its strategy and solution. So in our day-to-day life, we come across various IoT devices. For example, if we see the watch that we wear, the smartwatch in it nowadays is IoT enabled. Also, if we see the vehicles such as trucks or let's say car, it is IoT enabled devices nowadays. Also, in home appliances, if we see our refrigerator as well as even a coffee machine nowadays are IoT enabled. In industry, if we see there are lots of machineries, for example PLC, or if we take example of industrial robotic arm, it is also IoT enabled nowadays. If we see the market stat of these IoT devices, we'll find that over 800 800 800 billion dollars of market it has, and till 2025 it is going to become up to 1.1 trillion dollar. So it is very essential to check how what IoT stand in our in the whole industry. Yeah. To build this IoT application, we will need a IoT platform too. So there are different IoT platforms available, and the most leading IoT platforms is Microsoft Azure, AWS, ThingsWorks PTC. Also, we have this IBM Watson IoT as well as Google Cloud. So it offers us the capability to create our own IoT application on the IoT platform itself. So I would like to tell you how actually IoT work using the IoT ecosystem. So if you are able to see my screen, I am sharing this IoT ecosystem block diagram. Any IoT ecosystem consists of five components. The first is IoT devices, the next is IoT hub, the third is data store, then we have this analytics UI, and the fifth is enterprise system and application. The IoT devices sense the data from the environment, it gather all the data and it sends back to the IoT hub. So here the IoT hub act like a so Yeah, so this IoT hub actually acts like a central repository where we can dump all our IoT data from the millions of devices, which are coming from the millions of devices. So when we get all the data, this data we can send it to the data store. It will store under the different databases, different data sets. Also, we can store it in the blob storages. So whatever the data that we have stored, that we can use for the further analytics, or we can apply some AI or ML model on this data that we are gathered, and we can extract some useful information or business insight from this data that we have gathered from the IoT devices using the analytics, AI as well as ML. After that, whatever data business insight that we have gathered and whatever the data that we are getting from the IoT devices, we can show all the data as well as this business intelligence in the enterprise system and as well as applications. So basically the enterprise system as well as application is nothing but the web application that we developed, or we can take example of Android application. It is the example of this enterprise system. So this is how actually the IoT ecosystem work, and this is the flow of any IoT application from IoT device to IoT hub. Then it will store to the data store. It will do further kind of analytics on the data, and it will show us the data on the enterprise system, or we can say we can visualize all the data on the enterprise system. So as I told that there are some hyperscaler which is most prominent in the IoT industry. So the first is Microsoft Azure, the second is AWS IoT, and we have this cloud, Google Cloud. So these are all the most three prominent IoT cloud platforms available nowadays. Since this IoT ecosystem consists lots of different component, it has some complex QA challenges that we must solve. So the first QA challenge is like how to perform the accelerated end-to-end testing. If we see in the market right now, there is no any particular end-to-end automation testing framework available to test whole. end-to-end IoT application. So this is the one challenge. The next is, as I told you, there are different kind of technologies or components available in the IoT ecosystem. For example, we can have edge, we have the cloud, then we have the storage, analytics, web API, then mobile and machine channels. So such kind of different component testing these different component is really difficult at the same time. So this is the next challenge that we have. And the third is, as we are taking the data, and uh, we are just taking the intelligence from the data. We are using this expensive AI models for expensive AI models and all. And we can't assure, like, how can we assure the intelligence that we are getting from the data? So this is the third complex QA challenge that we found. So to resolve all these challenges, we have created one end-to-end automation testing framework, which can test our whole IoT application at the same time. It can test the all the components, and also it assures the intelligence from the data. So I would like to tell you how actually any IoT platform work. So we will take example of Azure. So in any platform, there will be a four layers. First will be the IoT device layer. The next will be a telemetry ingestion layer. The third will be a storage and analytics layer, and fourth will be a application integration layer. So in IoT device layer, we'll have the different assurance zones. Like we can test that things like IoT device, edge device we can test, IoT devices we can test. So yeah, so these are all the assurance zones. Also in telemetry ingestion layer, we can test the cloud gateways, IoT hub, function app, data transformation app. In Also in storage and analytics, we can test UI reporting as well as tool. We can test stream analytics. We can do the testing on the database such as Cosmos DB or any other databases, or we can do the testing on storage blobs. At the same time, on application integration layer, we can check the front end as well as APIs. We can do the testing of machine learning models. We can do the testing of logic apps. So such kind of testing or such kind of assurance zones we will get in the on the any kind of IoT platform. So if we see my screen here, we these are all the testing we can do. We can perform using the end-to-end automation test framework that we have developed. For IoT device layer, we can do the testing of device connectivity. We can test error message validation. We can do a protocol converter test. We can check the firmware as well as the message throughput. Similarly, in telemetry ingestion layer, we can test the authentication. We can check device registration. Similarly, we can check IoT hub quota as well as throttling. So such kind of testing we can do in the telemetry ingestion layer. After that, we'll have the next layer, which is a storage analytics layer, where we can test streaming payload test, data map test, schema validation, data integration, as well as business rule validation. Similarly, on application integration layer, we can test multi-channel apps, compatibility of any app, interoperability, API, as well as business logic tests. So such kind of testing we can perform with this end-to-end automation testing framework. So how actually this end-to-end automation framework works? So basically, if we see ingestion assertion, it means we can simulate data such as age messages, device config, device state, device telemetry. All the data we can simulate, and this data we can dump it to the different component of a IoT application. For example, if we wanted to test IoT hub, we'll send the data. We will check whether we are getting a data in the IoT hub. We can, using a simple assertion technique, we can check whether it is working fine or not. We will get a reports whether it is working fine or not. Similarly, we can test streams, storage, analytics, alerts, identity, as well as device managers. So we were using a different we are using a different APIs that they all the platform export, and using that API we are going to test all these components. Apart from this all testing, we can perform a web application test, mobile application, enterprise API test, enterprise backend test, ERP systems, wearable voice assistant, as well as chatbot testing using this automation framework. So this automation framework supports use has the ability to integrate using a CI/CD tool. We can integrate with ALM as well as Jira tool. Also, it has a ability or capability of scheduling as well as execution of agent, and it has a capability of it will show the result on the dashboards. So the framework we have built using the IoT device libraries and the IoT platform library for Azure, AWS, as well as Google, and the application and integration libraries. So this is how it actually this we have built this automation framework. And the good part of the this framework is it is available in both Python as well as Java. So if you have already written a script in Java, then you can integrate this whole automation framework with your already written script, or you can use the Python libraries to write the a further script. So this is how exactly this IoT end-to-end automation framework look like. And the next framework is like it is an enhanced version of this IoT end-to-end automation framework, which we can use to test the industrial IoT. We will show you the demo how it actually work. So in this end-to-end automation testing framework for the IIoT, there will be a different component. Like in industries, we will have the SCADA, PLCs, historian, and other machineries, which will send the data to their connectivity platforms such as Ignition, Capture. From that platform, we will send this data to the edge, such as a compute, storage gateway, as well as ML model. And after that, we can send the data to the cloud analytics and insights. After that, whatever the data we are getting, we can see it in the enterprise backend or other enterprise services or the other another consumer channels such as mobile app as well as web app. So this is how actually any IoT application work. We will show you the demo how it actually work. Uh, how it actually works. Yeah. This whole IIoT platform uses a different kind of libraries too. It is an expansion of the IoT framework that we have developed. So right now we are using OPC server client libraries, Ignition and Capeware libraries. Also, we are using this Edge SDKs, Greengrass, as well as IoT Hub libraries. The storage libraries, Stream and Kafka validation also we are going to use in that. So we are using that also. Uh, so and the consumer channel libraries also we are using. So using this all library, we have built this IoT automation framework. So I would like to tell you what are the benefits of using this end-to-end automation testing framework. So as I told you, this automation framework is available in Eclipse plus test engine means Java as well as Python. So you can use either Java framework or a Python based on your existing framework. The next is it is really easy to understand, and we can reskill the any associate for this IoT framework. The third is like it supports a seamless integration of with any cloud, and it has a DevOps ecosystem as I told. And it can be seamlessly integrate with the multi-channel QA utilities. Also, we have tried and tested this whole end-to-end automation testing framework for IoT in our many customer with our many customer, and we have found that we have almost reduced 30% of manual effort in IoT testing. This is how actually this end-to-end automation testing framework work. I will hand over it to Rishabh. He will tell how he will show the demo how actually this end-to-end automation testing framework works. Uh, Rishabh, can you take it?
Sure, sure, Aniket. Thank you for the giving a wonderful presentation of this IoT. I'll show this demo of IIoT, which already Aniket has explained on a high level overview, but I'll also explain how what it is and what we will be seeing in this demo. So here we have PLCs and sensors at the left hand, and it will send the raw data to any of the protocol adapter such as Ignition or Kepware. For this particular demo, we are using a Ignition protocol adapter, and we are using AWS cloud for testing this IoT platform. So moving forward, it will send that what Ignition will do is it will take the raw data from the PLC or sensors and will uh, attach the timestamp in that, and will convert that raw data into a proper format such as JSON, and will send that data to a Greengrass component, AWS Greengrass component. Uh, then that in from the green grass that green grass will be sending that data to our cloud, which is AWS IoT core. So what our framework will do, it will do a three level testing. It will first take the data from protocol adapters such as Ignition with the help of open source Ignition libraries. Then it will take data incoming from the Greengrass. It will retrieve the data from the Greengrass, and also it will retrieve the data from the AWS cloud. And it will check all of these three data if it is it will check all of these three data if it is correct or not, if it is in correct format or not, and the starting data correctly matched to the end user application data or not. So let us begin this video. So first, what I will do is I will use a Ignition demo account, and I will create some sensors for simulating some data, as we don't have a real industrial device with us. We are using this Ignition software, which have the capability to simulate any sensor data. So here I'm creating a new device. We can see it has already filled with most of the sensors libraries, which we can create and simulate the data. So I will be creating two sensors and simulate the two sensors data, and will sending that data to AWS Greengrass component. I will be creating temperature and pressure sensor, which will be sending. Here you can see I have created two uh, sensors, two simulator sensors. One is temperature and one is humidity, which will have a random data. I have also given the range of the random data, and what will be the data type and time interval. I have all have given that. So when I will start the simulator, it will send that data to our Greengrass component. So moving forward, I have I have installed one Greengrass component in a Ubuntu machine, which is a EC2 instance, and all of that credentials of that Greengrass, like their certificates and their endpoint, I have written down in the settings. In the connection of the Ignition software, so that it can easily connect with our Greengrass component. Yeah, so this is a green grass. It is a Ubuntu machine which I have accessed using the Putty software. In this, we can see that green grass has successfully started, and it will receive data, and the green grass will AWS green grass will start sending the data to our AWS core. So to see that data in the AWS core, we will be using subscribe method in the AWS account. In the MQTT test client, we will subscribe to a particular topic from which we can see all the data incoming from the Greengrass. I'll show you that. Here we can see this MQTT test client, right? So here I'll subscribe to a particular topic, and we can see all the data incoming. You can see that timestamp, and there are two data we are getting: humidity and temperature. So these all the data are coming to the cloud, passing through the Greengrass. So So these data will be stored in a S3 storage, AWS storage, cloud storage, and then that data will can be used for creating our end application and can be used in our end application. Then coming to the our framework, we have built this framework using Python language, and we have used robot framework to create test reports and test log files. So in this we will be running one simple test case. So what it will do is it will first connect to our ignition software with the Python client libraries. It will access all the data incoming through the ignition. Then it will connect to our AWS cloud and also AWS Greengrass. Uh, these are all the Python codes we will be using to connect to our components. Then after receiving a data with a particular time, for example, we have given for 10 second, it will receive the data, and for 10 second it will check if the data which is sent through the ignition is same as that which is received at the end application of the cloud. So here we have ran the first test case and it has passed. So moving forward, I'll show you the report, how it will look, and what all it will give us. It, Yeah, so this is the report file which we will be getting. We can see that in the first suit we have ran a test case and it has passed successfully. And the print message we can see is first it will connect to our AWS cloud. It has received all the AWS data. We can see we have received 10 different datas, and then it will disconnect to the AWS. Then it will connect to our ignition, and it will receive all the ignition data, and at the end it will check if both the data are same or not. So then it will assert that yes, there is not any packet loss or any type of error in between when the factory sensor will send data to the end application passing through the Greengrass or AWS cloud. So that's how our framework will work. So that's all we want to show you. If there is any questions, we are open to the questions. Uh,
Uh, Rishabh, thank you.